Today we are going to discuss types of discontinuity and how to illustrate them. First, what is a discontinuity? For brief introduction, the function of the graph which is not connected with each other is known as a discontinuous function or discontinuity. A function or f of x is said to have a discontinuity of the first kind that x equals a if the left-hand limit of f of x and right-hand limit of f of x both exist but are not equal. What are the types of discontinuities? First, we have removable discontinuity, then infinite discontinuity, and jump discontinuity. So what is a removable discontinuity? Removable discontinuity occurs when the function and the point are isolated. Essentially, a removable discontinuity is a point on a graph that doesn't fit the rest of the graph or is undefined. In the illustration given, these lines these lines are supposed to be connected, but they're both discontinued because of this circle that is unshaded. As we observe in the graph, aside from the circle that is unshaded, there is also a circle that is shaded, aligned to the circle that is not. This is an example equation of a removable discontinuity. We are given an equation of f of x is equals to x squared minus 2 over x minus 2 minus x squared minus 4 over x minus 2. This equation is a discontinuity because it if you graph it, it will be discontinued or it is not continuous. If you graph it, it is graphed or equated or illustrated like this. As you can see, there is still an discontinuity. So to make it a continuity, we factor the numerator, giving us with a quantity of x plus 2 multiplied to the quantity of x minus 2. And we copy the numerator. Given that there is an x minus 2 both in the numerator and denominator, we could cancel it, giving us with x plus 2. As we all know, x plus 2 is a line and line is always continuous. So what we did was we converted a discontinuity to a continuity. And when a discontinuity can be converted to a continuity, it is a removable discontinuity because we removed the discontinuity and replaced it with a continuity. What is an infinite discontinuity? This occurs when you look at the domain of the function and at some point both the upper and lower limits or just one of them do not exist. It exists when one of the function's one-sided limits is infinite or one of the other three varieties of the infinite limits. In the illustration given or in the graph given, we can see that both lines or curves do not meet, and given the arrow, it illustrates that they both go upwards continuously or without an end. For example, f of x is equals to 1 over x squared, and we are given a vertical asymptote of x is equals to 0. If we substitute the equation, if we change x into 0, we will have 1 over 0, making the equation undefined. Given the undefined equation, we can see that the graph don't meet because the 0 is equal, the x is equal to 0, sorry. This is why it's called infinite discontinuity, because it continues without an end, but the line never meets, or it is a discontinuity. What is a jump discontinuity? Jump discontinuities exist when entire portions of the curve jump instead of normal curve having a single point jumping action. Jump discontinuities occur when the function starts to jump between different points in the graph. In this illustration given, as we can see, or as the description said, both the points, both are with different points, or they are not at the same point, which made them not connected and away from each other. As you can see or visualize, this may look like the point jumped upwards. For example, f of x is equals to the abs- in this equation, the absolute value of x is over x. We can observe that the denominator is x, so x cannot be equals to 0 because it will be undefined. So we give the situation where x is greater than 0 and x is less than 0. And if the situation is x is greater than 0, we will have an answer of positive x over x, or positive 1 over 1, giving us with 1. If the situation is that x is less than 0, we will have negative x over x, negative 1 over 1, which is equals to negative 1. In this illustration, positive 1 is over here, it is shaded, and the negative 1 over here is unshaded. Given that they are both different values, since negative 1 and positive 1 are both different values, they jump, or they discontinuity, or they discontinue rather. As you can see, they are not connected, and this is a sign of discontinuity. So that is all for today, and I hope you learned a lot. See you all in the next video.